Alright, in this video, our focus is going to be on charge quantization and Coulomb's law. So first, we're going to start with charge quantization. Now, charge quantization is a measure of the quantity of charge possessed by a body. Charge quantization is a measure of the quantity of charge possessed by a body. It simply has to do with how much charge do we have in a body. Now, mathematically, it is given as Q equals plus or minus NE. Q here represents the quantity of charge. N is the integer, that's the number of subatomic particles. Alright, the number of subatomic particles, that's either the protons or the electrons. And E is the charge on an electron, which is 1.6 times 10 raised to the power minus 19 coulombs. Now, we have Q equals plus or minus NE. We use plus when we are solving for proton. The quantity of charge we're looking for is a proton, all right? And then we use minus when we are solving for electron. Now, looking at this question, it says find the number of electrons in minus 2 microcoulomb charge, all right? So the quantity of charge is minus 2 microcoulomb. Find the number of electrons in minus 2 microcoulomb charge. So first we bring out our parameters. Q was given to us, and Q is equal to minus 2 microcoulomb. Take note, we are solving for electrons, so we are going to be using minus here. We have Q equals minus 2 microcoulomb. Find the number of electrons. Electrons are the subatomic particles. We are looking for number of subatomic particles. So it simply means we're looking for N. So we have N unknown. Now the formula that connects these two is Q equals NE. Alright, Q equals NE. That's the formula that connects these two. But then we are solving for electrons. Find the number of electrons. I remember I said if you're solving for electrons, you use minus. If you're solving for protons, you use plus. So since we're solving for electrons here, we're going to have Q equals minus NE. And Q was given to us to be minus 2 microcoulombs. Minus 2 microcoulombs. Micro here means 10 raised to the power minus 6. This symbol here means 10 raised to the power minus 6. So our quantity of charge is minus 2 times 10 raised to the power minus 6 equals minus N, alright, E. That's N times E. And E is a constant. Don't forget, E in this formula is always constant. So whether they give it to you in the question or not, have it at the back of your mind that E is always equal to 1.6 times 10 raised to the power minus 19. So we have minus N times 1.6 times 10 raised to the power of minus 19. So we are looking for N. We try to simplify. This is going to be minus N times this, which is minus 1.6 times 10 raised to the power of minus 19 minus 19N, alright, equals this times this, which is minus 2 times 10 raised to the power of minus 6. So to get N, we divide both sides. We simply divide both sides by minus 1.6 times 10 raised to the power minus 19. So we can get N. If we do that, we're going to have minus 1.6 times 10 raised to the power of minus 19N divided by minus 1.6 times 10 raised to the power of minus 19 equals minus 2 times 10 raised to the power of minus 6 over minus 1.6 times 10 raised to the power of minus 19. Now this is going to cancel out the whole of this, so we are left with just N equals this divided by this. So if we use our calculator, we're going to arrive at minus first to cancel out minus here, so we left with 2 times 10 raised to the power minus 6 divided by 1.6 times 10 raised to the power minus 19, which is 1.25 times 10 raised to the power 13. Alright, so this is the number of electrons, so we'll say electrons. So this is our answer to this question. Now looking at this question here, it says how many electrons are contained in 320 times 10 raised to power 25 coulombs of charges, given that each of the electron carries a charge of 1.6 times 10 raised to power minus 19 coulombs. Again, they said how many electrons? How many electrons? Electrons here are the subatomic particles. All right, so we are looking for the number of subatomic particles. And remember in our formula, number of subatomic particles, the symbol is N. So we are looking for N. How many electrons are contained in 320 times 10 raised to power 25 coulombs of charges? So this is the quantity of charge. We have Q given to us again. 320 times 10 raised to power 25. All right. Given that each of the electron carries a charge of this. So we have charge on an electron 1.6 times 10 to the power of minus 19 coulombs. Now we fall back to our formula, which is Q equals NE. Okay, so Q is 320 times 10 to the power of 25. But do not forget, it's not just going to be Q equals NE, all right, but Q equals minus NE. All right, how many electrons are contained in this? Okay, so since this is an electron, this is even supposed to be negative. This is supposed to be negative, though it was not included in the question, but it's supposed to be negative, so it's going to balance up our answer. Okay, so we have this. This is supposed to be negative because it's an electron. The quantity of charge will be negative. Okay, so we have Q equals minus NE. This is Q minus 320 times 10 raised to the power 25. That's the quantity of charge. And then we have minus N times E. E is 1.6 times 10 raised to the power minus 19. If we multiply this together, we're going to get minus 1.6 times 10 raised to the power of minus 19 n equals this times this. That'll give us minus 320 times 10 raised to the power 25. So you divide both sides by this. So we're going to have minus 1.6 times 10 raised to the power of minus 19 n all over minus 1.6 times 10 raised to the power of minus 19 equals minus 320 times 10 raised to the power of 25 over minus 1.6 times 10 raised to the power of minus 19. This is going to cancel out the whole of this, and then we'll be left with just n on the left hand side of the equation. So we have n equals, okay, now we use our calculator to simplify this. First, minus is going to cancel out minus. Then we have 320 times 10 raised to the power 25 320 times 10 raised to the power 25 divided by 1.6 times 10 raised to the power of minus 19. Okay, so that will give us 2 times 10 raised to the power 46 electrons, which is a very big number, and this is an integer. So this is the number of electrons. Now let's talk about Coulomb's law. Coulomb's law is very important because it explains the magnitude of the force that exists between two charges. Okay, Coulomb's law explains the magnitude of the force that exists between two charges. Now it states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of their distances apart. So talking about Coulomb's law, let's say we have two charges, Q1, charge 1, and then Q2 being charge 2, separated at a distance or separated by a distance, let's say r. Based on Coulomb's law, or like it was stated here, Coulomb's law is important to deduce the magnitude of the force that will exist between these two charges. If these two charges are positive charges, the force will be repulsion, force of repulsion. Let's say this is a positive charge, this is a positive charge. They are going to repel each other. That's, they are going to push away from each other. Okay. Now, if this is a negative charge and this is a negative charge, it's going to be a repulsion. They're going to be moving away from each other with a force. Now, if this is positive and this is negative, what we are going to have is attraction. They're going to be attracted to each other with a force. Now, Coulomb's law is useful in getting that force or knowing the magnitude of that force, because the force of attraction is going to be with a magnitude the same with the forces of repulsion. Now, according to Coulomb's law, the force between these two charges, if the two charges are separated by a distance r, the force of attraction or repulsion, all right, is directly proportional to the product of these two charges. So let's say we have the two charges to be Q1 and Q2. The force of attraction or repulsion will be directly proportional to Q1 times Q2. So we have F directly proportional to Q1, Q2, and inversely proportional to the square of their distances apart. The distance between them is r. So say inversely, we'll write it this way, inversely proportional to the square of their distances apart. R is the distance, so we square it. So this is Coulomb's law. Force of attraction directly proportional to the product of the charges and inversely proportional to the square of the distances apart. So this is the mathematical expression for Coulomb's law. Now, to convert this to an equation that we can use to solve problems, we need to introduce our constants. Okay, so we have F. As we bring in our equal to sign, it becomes an equation. Then we need to introduce our constant, which is K. So we have F equals K Q1 Q2 all over R squared, where F is the force of attraction or repulsion between these two charges, K is the constant, Q1, Q2 is the magnitude of each individual charge, R is the distance between the charges. Alright, so this is our equation or mathematical equation for Coulomb's law. Now, K is a constant, and mathematically, K is equal to 1 over 4 pi epsilon 0. Epsilon 0 is permittivity of free space, and it is equal to 8.85 times 10 raised to the power of minus 12. So if we plug that into this equation, we're going to have 1 over 4 pi times 8.85 times 10 raised to the power of minus 12. Alright, now if we use our calculator to simplify this, we're going to get approximately 9 times 10 raised to the power 9. So this is the value of K. Alright, so this is the value of K. You should know it has a unit. It is Newton meter squared per Coulomb squared. Alright, so this, the whole of this is the value of our constant K. So whenever you're using this formula, just have it at the back of your mind that K is equal to this. This is the value of K. It's a constant. It's always equal to this. So this formula can be written this way: F equals K Q1 Q2 over R squared, or it can be written this way also: F equals, you can write it as Q1 Q2 over 4 pi epsilon 0 R squared. Alright, because by the time we bring in K, which is 1 over 4 pi epsilon 0 into this equation, we have 1 times this, we have this. 4 pi epsilon 0 times R squared, we have this. Or you can also write it as 1 over 4 pi epsilon 0 dot Q1 Q2 over R squared. Alright, so these are the different ways you can write this, the formula for Coulomb's law. either like this or like this. All right, but I prefer going with this whenever I want to solve a problem. I just say F equals KQ1 Q2 over rho squared, and then I know that K is equal to this, and I solve. So we're going to look at a typical example or an example of a question here before we move ahead. Now look at this question here. It says 2-point charges Q1 equals this. All right, so we know that Q1 is equal to plus 25 microcoulomb, and then Q2 equals minus 75 microcoulomb. Please, the positive sign and the negative sign here are just important to tell you the type of force that will exist between them. You can see here we have a positive charge, we have a negative charge. That's to say the force that will exist between them will be the force of a force of attraction. All right. In other words, it's also used to tell you the direction of the force. Okay, so if you have positive charge and negative charge, you know it's force of attraction, they are moving towards each other. If it's positive, positive, force of repulsion, they are moving away from each other. As force is a vector quantity, so it's supposed to have magnitude and direction. All right, so please take note. Positive here and negative here is just useful to tell you the direction of the force. All right, you can ignore this when solving for the magnitude of the force. All right, so now moving on, we have 2-point charges. Q1 equals this, Q2 equals this, are separated by distance r equals 3 cm. R is equal to 3 cm. It's a find the magnitude and direction of the electric force. All right, so we want to calculate the force, but please, we need to ensure that every quantity here is in their standard units. All right, the unit for charge is coulombs, not microcoulombs. Micro here is a prefix, so we need to remove this micro. So this is now going to be plus 25. Okay, micro means 10 raised to the power minus 6. So we have plus 25 times 10 raised to the power minus 6 coulombs. And then Q2 equals this. So we have minus 75 times 10 raised to the power minus 6 coulombs. All right, this and this micro, they are micro is a prefix, it means 10 raised to the power minus 6. We also have other prefix like nano, small letter n, meaning 10 raised to the power minus 9. We also have pico, 10 raised to the power minus 12. We're going to be using these guys a lot, so please take note of them. So we have this and this. Now r is 3 cm. We need to convert it to meters because the standard unit for the distance is meter. So we have 3 divided by 100. 3 over 100 in meter. So that will give us 0.03 meter. Alright, so now we can go on and solve. We're looking for the magnitude and direction of the electric force that will exist between these two charges. So first, let's calculate the magnitude. So say F equals K Q1 Q2 over R squared. So we have K. What is K? K is a constant. Remember, I've told you before, K is a constant and K is equal to 9 times 10 raised to the power 9. Even if you're not given the question, have it at the back of your mind that K is always 9 times 10 raised to the power 9. So see 9 times 10 raised to the power 9 times Q1 is 25 times 10 raised to the power minus 6. So we have 25 times 10 raised to the power minus 6 times Q2. Like I said, ignore the sign, it's just there to tell you the direction. Let's just get magnitude alone first. So we have Q2 to be equal to 75 times 10 raised to the power of minus 6 all over r squared. R is 0.03, so we have 0.03 squared. So now we can use our calculator to solve this. So we have 9 times 10 raised to the power 9 times 25 times 10 raised to the power of minus 6 times 75 times 10 raised to the power of minus 6 divided by 0.03 squared. Okay, so that will give us 18750 Newton. So this is the magnitude of the force. Now the direction. So we have find the magnitude and direction of the electric force. To get the direction, we now use our signs, positive and negative here. If we have a positive charge and a negative charge, we're going to have a force of attraction. All right, they're going to be moving towards each other according to our law of electrostatics. Unlike charges attract, like charges repel. So this is a positive and a negative charge. We're going to be having a force of attraction towards each other. So this is going to be F equals 18750 Newton. All right, the direction of the force is we have force of attraction. That's a force of attraction. All right, or we can say 18750 Newton, 750 Newton towards each other, towards each other. Okay, so this is the magnitude of the force and direction. All right, so that is it for this question. Now moving on, this one here says calculate the value of two equal charges if they repel each other with a force of 0.1 Newton when situated 50 cm apart in vacuum. Calculate the value of two equal charges. All right, calculate the value of two equal charges if they repel each other with a force of 0.1 Newton. So we have the force in this case to be 0.1 Newton. Now we want to calculate the value of two equal charges. So let's say charge 1 is Q. Charge 2 will also be Q. Why? Because he said the two charges are equal. Okay, if they repel each other with a force of this. Now when situated 50 cm apart, so that means the distance of separation is 50 cm. All right, so we're looking for Q in this case. Now R is 50 cm. We need to convert it to the standard unit, which is meter. So we say 50 divided by 100. And that should be 0.5. So we have 0.5 meter. Now we simplify or we bring out our formula. We're looking for Q here. So we are going to have F equals K Q1 Q2 over R squared. We plug in our values. F is 0.1, so we have 0.1 equals K is 9 times 10 raised to the power 9 times Q1 is Q, so we have Q. Q2 is also Q. The two charges are equal. Then we have times. Okay, so that's it. K Q1 Q2. Okay, all over R squared. R should be R is 0.5 squared. Alright, so at this point we simplify and that will give us, first let's multiply this. We have this times this times this. Q times Q is Q squared, so we have 9 times 10 raised to the power 9 times Q squared. That will give us 9 times 10 raised to the power 9 Q squared equals 0.1 times 0.5 squared. 0.1 times 0.5 squared. So to get Q, divide both sides by 9 times 10 raised to the power 9. So we have 9 times 10 raised to the power 9 Q squared. Alright, divided by 9 times 10 raised to the power 9 equals 0.1 times 0.5 squared divided by 9 times 10 raised to the power 9. This we cancel out this and then we'll be left with just Q squared equals this divided by this. So use our calculator now. We have 0.1 times 0.5 squared divided by 9 times 10 raised to the power 9. That will give us 2.78 times 10 raised to the power of minus 12. Now we're looking for Q. It's the value of two equal charges. So we need the value of each individual charge. Alright. So to get it, we take the square root of both sides. This is squared, Q squared. That's not what we're looking for. We're just looking for Q. So to remove this square, we take square roots of both sides of the equation. We have square root of Q squared equals square root of 2.78 times 10 raised to the power of minus 12. Okay, so square root cancel squared, and then you have Q equals, so we have square root of, this will give us 1.67 times 10 raised to the power of minus 6 coulombs. Alright, so this is the value of each individual charge. Now for our next question here, it says calculate the force of attraction between electron and proton in a hydrogen atom. Okay, the force of attraction between electron has a charge of, is a constant, 1.6 times 10 raised to the power of minus 19 coulombs. Proton also has a charge of 1.6 times 10 raised to the power of minus 19 coulombs. The only difference is that electron is negatively charged, so we're supposed to have minus here. Okay, and this is this. Find the value, calculate the force of attraction between electron and proton in a hydrogen atom, assuming that their distance of separation. So the distance between them is 5.3 times 10 raised to the power minus 11 meter. Okay, so we need to get the force of attraction between electron and proton. Alright, but not just electron and proton anywhere, but electron and proton in a hydrogen atom. So let's bring out our formula first. We have F equals KQ1 Q2 over R squared. So from our formula, we have F equals KQ1 Q2 over R squared. Now we have F equals, this will give us F equals K is a constant, and it means it's equal to 9 times 10 raised to the power 9. Alright, don't forget K is always equal to 9 times 10 raised to the power 9. Q1 and Q2. We can say the electron, let the electron be Q1 and then the proton be Q2. Alright, everything is already in their standard units. This time is also in meters, so we just plug in and solve. So we have times Q1 being 1.6 times 10 raised to the power minus 19 times Q2 being 1.6 times 10 raised to the power minus 19 all over, we have 5.3 times 10 raised to the power minus 11, right, squared, all squared. So if we substitute into our calculator, we're going to have F equals, this is 9 times 10 raised to the power 9 times 1.6 times 10 raised to the power of minus 19 times 1.6 times 10 raised to the power of minus 19 divided by 5.3 times 10 raised to the power of minus 11 all squared. Okay, so that will give us F to be 8.20 times 10 raised to the power of minus 8 Newton. So that's the force that will exist between the electron and proton in a hydrogen atom. Okay, so that will be all for this video. If this video was of great help to you, please subscribe to our channel using the subscription button below this video. Just tap on the button, that's all. This will help to increase the visibility of our videos. Thank you and see you in the next video.